So let's recall what an isomer is. So two compounds are said to be isomers when they have the same exact molecular formula but different structures. So in this lecture we're going to focus on cis-trans ZE isomers. So let's begin by looking at the following alkene that has the following molecular formula: C2H2XY, where XY are simply two different compounds, molecules, or atoms that are not H atoms. And let's begin by trying to figure out the three-dimensional structure of this alkene. So alkenes have the following structure. So we have a double bond. The lower bond is the sigma bond. The upper bond is our pi bond. So lower bond sigma, upper pi bond. We have the two intersections. So these are the carbon atoms shown here. And here we have the two H atoms given in red, and the X atom, the green atom, and the Y atom, the blue atom. Now, one important detail about the structure of alkenes is that they have planar symmetry. In other words, all these four atoms are found on the same exact plane. So if this was the XY plane, all these four atoms would be on the same plane, and these four bonds are also on the same plane. Now, whenever we have the two H's on the same side of the plane, or the X and Y, the heavier atoms, on the same side of the plane, we have cis or Z compounds or molecules. In other words, we define C compounds as hydrogens being on the same side, and we define Z compounds as having the heavier groups on the same side. Remember, we defined X and Y to be any compound, molecule, or atom that is different than H. And that means our X and Y are both heavier than H's. So, this compound is one isomer of this molecular formula, and it's the cis or Z isomer. What about trans or E? Well, let's recall another important detail about alkenes. Alkenes have double bonds, and that means we can't rotate this molecule. The only way we rotate this lower bond is if we break the pi bond. The only way we break the pi bond is if we input energy. So let's say we input energy, exactly 66 kilocalories per mole of energy, then we'll break the pi bond, and our bond, our CC bond, the lower CC bond, will rotate. And then let's suppose it rotates, we take away the energy, and our pi bond reforms. We will get the following molecule. So in this molecule, we have the H's are on the opposite sides, and the X and Y are also on the opposite sides. So we have the following picture. So we have the two H's being on different sides, and we have the Y and the X also being on different sides. So trans is defined the following way. Hydrogens are on different sides of the plane. X and X, different sides, H and H, different sides. And E is defined as the heavier groups are on different sides. So once again, our X and Y are on different sides. Now, these two guys are isomers to one another, and they're separated by 66 kilocalories of mole. So, let's look at the following few examples, and let's try to figure out which ones are E and which ones are Z. So we're looking for the heavier groups and the lighter groups. So we have two methyl groups and two ethyl groups. Ethyl is heavier. That means these guys found on the same side are the heavier groups. And so we have the heavier groups on the same side. So that means we have our Z. So this must be Z. So what about this guy? Here we also have methyl and ethyl, but the ethyl groups are on different sides, and the methyl groups are on the same sides. So that means the lighter are on the same sides, on different sides, the heavier are on different sides. So that means we must have our E. So this is E. What about this guy? Well, now we have a methyl, we have an H group, we have an ethyl, and an ethyl. So once again, we have the two ethyls are on different sides, the two heavier groups. And that means we must have our E. Well, what about this last one? Here we have two methyl groups attached to the same carbon. So these two groups are identical. And that means there's no way to distinguish between these two guys because they have the same exact weight. And that means there are no isomers of this compound. E or Z or cis or trans do not exist for this guy.